This is my first attempt at a bipolar Tesla coil with a Slayer exciter circuit. This is the Slayer exciter circuit that I took the reference from. You can see the transistor is a 25A1962. It's a PNP. And that means we're pulling the negative on this one. So we got all the connections made. Now I made a modification over here and I put two diodes in here. This is a 400 volt 3 amp diode. This is a 100 volt 1 amp diode. And the goal is simple. I wanted to see if it would spark, number one. Slayer exciter, I don't think I would expect it to, but you never know, and so I put it out there. But I just wanted to see if it would oscillate. Now, why the diodes on the bottom there? Well, I'm trying to break the ground wire coming in, or excuse me, the forced oscillation wire that goes through the bottom normally on a Slayer exciter and goes to the top. So it's also got to be the other side of where it picks up the energy. So maybe it works. Maybe all I did was shorten my Tesla coil. Who knows? Give it a try, see if it even works, and then we'll go from there on what we need to do. So, with that said, we're going to check the temperature on this as we go on our transistor. So at 15 volts, we got light up at 15 volts. Okay. That means I have a little over 2 amps in it. We went up to 19 volts. Still lighting up. And got light up on that side. Not as consistent as I would like this to be. I don't have any fan running on this, so let's just check. Yeah, we're in the 70s, so we're good operating voltage, so let's go ahead and bring it up a little bit. We are now at 30 volts. See if our light gets any better. Our light got better. That's good news. Yep. Light's fairly good. By no means is this the same thing I get out of running it in normal configuration, I can tell you that. But it is lighting up. And at 30 volts, we're still in the 70s. That's still well within operating. So the connections, I just have it connected to the top. By no means is this set to oscillate in any different way, so we can change that. The other wire is standard. It just goes back down. Again, with the schematic I gave you, I haven't changed anything there. So let's take a look at our oscilloscope and see what kind of waveform we get out of it. So I just have the probe here. What I'm going to do is I'm going to bring it over this side, then I'm going to bring it over this side. So I'm going to show you the oscilloscope. There we go, you should be able to see that. We're over the right side now. Certainly interesting. We'll go over the left side. Let's see, we'll move back to the right side. Trying to keep everything about Same height. We're about 3 inches off the coil right now. Again, we're not getting a massive field. So let's put this over our primary. And it's almost nothing there. Alright, so let me see if I can't. That's our output right there. Yeah, we don't have near enough power in this thing, that's for sure. This is probably why it's always done with a spark gap Tesla coil. It's okay. This is what testing everything is. So we're going to bring this thing up just a little bit in temperature. And that means I'm going to put the voltage up a bit. We are now at 40 volts. There's no fan on this right now, it's just the transistor. And we're still 85, still in operating. And we got light on both sides. Goes out just a little bit, not much. This other one, yeah, I broke it in half. Let's see the temperature after a while that it's run. And just so I can verify it for you, 40 volts. That puts me right around 8 amps. And the station's in the mid 80s. So, is it a true bipolar? Probably not. Not with without that spark gap and everything else. But it'll give me a chance to see, if I connect my ZVS later to it, a way to get it to operate. And then we'll see if it works that way. But yeah, it's operating at 40 volts. Was there a breakout still? And no, there's not near enough amps in it to get it to break out like that. Anyway, I hope you enjoyed the video. Thank you.